Let's try and factor this expression here. So if we see an expression like this, the first thing that we can notice is that we have a sum of cubes. 64x to the 12th power is a perfect cube, and so is 125. So first, let's determine what the cubed root of 64 times x to the 12th power is. Well, we know that 4 cubed is going to give us 64. So it's going to be 4x to some power that's cubed to give us this result. And a simple way that we can figure out what our degree of x is going to be when it's cubed and gives us this result is to figure out what we can multiply by 3 to give us 12. And we know that 4 times 3 is equal to 12. So our x should be raised to the 4th power. And we can validate that we've done this correct by just calculating this. So 4 cubed is 64, and x raised to the power of 4 times 3 is 12, and that's what we have here. Then 125, the cubed root of 125 is 5, because 5 times 5 times 5 is 125. So now we have our a and our b. And again, let's just write down this formula for simplicity's sake, and so we can refer back. So we know that when we're factoring a sum of cubes, we are going to have a plus b multiplied by a squared minus ab plus b squared. And that is our formula for our factored form of a sum of cubes. And now we have our a. Our a is going to be equal to 4x to the power of 4, and our b is equal to 5. So using this formula, we just plug in our a's and b's. So we have 4x4 plus 5 multiplied by a squared. So we need 4x4 squared minus a times b. What is 4 times 5? That's 20. And then we have our x4 here, plus b squared. So that would be 5 squared. And we can simplify that. We have 4x4 plus 5 multiplied by 4 squared is going to give us 16, because 4 times 4 is 16. And then we have x raised to the power of 4 times 2, which is 8. Then we have minus 20x4 plus 5 times 5 is 25. And this is our factored form for this expression right here. Now let's go over one more example. Let's try to factor the following expression. 8 times x to the power of 9 minus 64. Now what's different in this example is that instead of having a sum of 2 cubes, we have a difference of 2 cubes. And we know that this is a perfect cube and this is a perfect cube. We already know that 4 times 4 times 4 is 64. So this part is just going to be 4 cubed. And we know that 2 cubed will give us 8. So we're going to have 2x. And what can we multiply by 3 to give us 9? Well, 3 times 3 is equal to 9. So now we have our a and we have our b. And since our formula for the difference of 2 cubes is slightly different, let's just write that down here. So we're going to have a minus b, because since we're doing a difference, we know our sign is going to be negative here. And then we have a squared plus ab, since it has to be the opposite sign, plus b squared. And we know that this is always going to be positive regardless of whether we're doing a sum or difference of cubes. And now we have our a, which is 2x cubed, and our b, which is 4. So let's plug in our a's and our b's into this formula here. So we have 2x cubed minus 4 multiplied by 2x cubed squared plus a times b. So what is 2x cubed times 4? 2 times 4 is equal to 8. And then we have our x cubed plus b squared, which is 4 squared. And so let's simplify that. We're going to have 2x cubed minus 4. We're going to have 2 squared is equal to 4. 3 times 2 is 6, so 4x to the power of 6 plus 8x cubed plus 4 squared is equal to 16. And you might notice that we have common factors in each of these brackets. So we have a common factor of 2 in this bracket here, and here we have a common factor of 4. So we can actually factor those out and simplify this further. So if we factor out the 2, we're going to be left with x cubed minus 2. And here, if we factor out the 4, we're going to be left with x to the power of 6 plus 2x cubed plus 4. And because we have two factors that we've taken out, we can actually multiply these together. So 4 times 2 is 8. So we're just going to have 8 multiplied by our x cubed minus 2 and our x to the power of 6 plus 2x cubed plus 4. And this is our final answer and our factored form of this expression right here.